Good day, everyone. In this lesson, we will be discussing process management. Let us first define some important terms that will be used in this lesson. Job, also known as a program, is an inactive unit such as a file in disks. This entity contains at least two types of elements: program code and a set of data. Next, we have process, also called as tasks, is an executed program code on the processor that is a part of an active entity. Third, we have processes, are programs loaded into memory that takes alternating CPU and input output bursts. CPU burst or burst is the thinking process of the processor. Next, we have thread. A thread is a portion of a process that can be run independently. Lastly, we have process control block or PCB. A PCB is a data structure maintained by the operating system for every process. It keeps all the information needed to keep track of a process. Before we proceed with the main topic of this lesson, let us first take a short review about the purpose of an operating system. An operating system has three main functions. First, manage the computer's resources such as the CPU, memory, disk drives, and printers. Second, establish a user interface. And third, execute and provide services for application software. Process management. Let us now go to our main topic, which is the process management. Now, a process management entails a variety of tasks such as process creation, scheduling, process termination, and deadlock. It is the OS or the operating system's responsibility to manage all the system's running processes. Now, process management manages operations by carrying out tasks such as process scheduling and resource allocation. To understand the concept of process, let us take this illustration as an example. Process or processes are memory loaded programs that take alternating CPU and output or input output burst as defined earlier. Now, a process performs either an input or output activity as well as a processing activity. Consider the process of printing a document from a word processor. The control key plus letter P on the keyboard can be used, or control P. This is an example of an input burst because same keys may mean different things in different application software. The processor inside the computer will interpret what the command control P means in the word environment. A CPU burst is the processor's thinking process. Now, the print dialog box will be displayed on the computer screen once the purpose of the keyboard command has been determined. This is another input output burst, but this time an output burst which prints the document using the printer. All of these activities require the operating system to be busy passing inputs to the processor and sending the results to the appropriate output devices. The next topic in this lesson is process. Now, a process or task is a piece of active entity that is executed program code on the processor. Now, a process is an active entity, whereas a program is considered as a passive entity. When run multiple times, a single program can generate a large number of processes. Now, process may include text, stacks, data, and heap. Now, text includes the current activity as represented by the program code value. A stack is where temporary data such as function parameters, return addresses, and local variables are stored. Data, on the other hand, contains the global variable, and a heap, dynamically allocated memory to process during its runtime. A process has different attributes. The first attribute is the process ID, which is a unique identifier by the operating system. Next is the process state. It can be either ready, running, or any other. Now, anyway, we'll be discussing more of process states later on this discussion or in this lesson. Another is the CPU registers. Now, the CPU registers, these are types of computer memory that are used to quickly accept, store, and transfer data and instructions that are being used by the CPU at the time. Now, processor registers are the names given to the registers used by the CPU. Next, we have the I/O status information or the input-output status information, which specifies which input-output devices are to be assigned to a specific process. It also displays which files are open and the status of other input-output devices. Now, it describes data input and output from an input device to a register. Now, it describes data input and output from an input device to memory. Lastly, we have the CPU scheduling information. A CPU scheduling information is a process that allows one process to be used by the CPU while another process's execution is on hold or in a waiting state due to the unavailability of any resource such as input-output devices, allowing the CPU to be fully utilized. Now, remember that the goal of CPU scheduling is to make the system as efficient, fast, and fair as possible. In operating system, a process has different states. Now, process states describes the current state of a process such as whether it is ready, running, or waiting. A process can have one of the following five states at a time. Start. Now, this is the initial state when a process is first started or created. Another is, or the second state is ready state or is the ready state. Now, the process is waiting for a processor to be assigned to it. Ready processes are waiting for the operating system to allocate them a processor so that they can run. The process may either or may enter this state after leaving the start state or while running but being interrupted by the scheduler to assign CPU to another process. The third state is the running state, where after the OS scheduler has assigned the process to a processor, the process state is set to running and the processor executes its instructions. Next is the waiting state. Now, the waiting state, if the process needs to wait for a resource, such as for user input or for a file to become available, it enters the waiting state. And lastly, we have the terminated or exit state. When a process completes its execution or its terminated by the operating system, it is moved to the terminated state and awaits removal from the memory or from the main memory. So those are the different or the five different process states in an operating system. Let's now go to multiprogramming. The interleave or multiprogramming is the interleave execution of multiple jobs by the same computer. When one program in a multi-programming system is waiting for an I/O transfer, another program is ready to use the CPU. As a result, multiple jobs can be shared the CPU's time. Now, there are two types of multi-programming, the preemption and the non-preemption. Now, preemption, this is where the process is forcibly removed from the CPU. Preemption can also be referred to as time sharing or multitasking. So, when you have a program, multiple programs open in your computer system, that is an example of a preemption, multi-programming. Next, we have the non-preemption. Now, the non-preemption is where processes are not removed until they complete the execution. We now go to process creation and termination. Let us first discuss process creation. When we run, okay, when we run a program, a process is created that is terminated once the execution is completed. The newly created process is referred to as the child process, while the process that initiated it or the process when execution begins is referred to as the parent process. Now, a parent process can have multiple child processes. Okay. Now, in the system, a process for each operation can be created. The following are some of the events that lead to the creation of a process. First, we have the user request for process creation. Another is the system utilization. Third is the batch job initialization. And the third or the fourth, which is the execution of a process creation system called by a running process. Now, processes can be created or can create other processes by using system calls such as the fork or the spawn command. The next is the process termination. Process termination occurs when the process is terminated, of course. When or most operating system use the exit command system call to terminate processes. This process exits the processor, releasing all of its resources. Now, if its parent process requests it, a child process may be terminated. There are different types of process termination: the normal exit, the error exit, the fatal error, and the termination by another process. Now, normal and error exits are both voluntary, whereas a fatal error and termination by another process are not. So in the normal or error exits, which is voluntary, let's say for example you have a Word application open and you closed the application by clicking the close button or simply going to the file and then close option. So that is an example of normal, okay, exit. Okay, next topic is the process threads. Okay, so process threads, or a thread, simply we can call it as thread, is a basic unit of CPU utilization consisting of a program counter, a stack, and a set of registers and a thread ID. Threads are extremely useful in modern programming whenever a process has multiple tasks that must be completed independently of one another. In a word processor, for example, okay, a background thread may check spelling and grammar while a foreground thread processes user input or keystrokes. A third thread loads images from the hard drive, and fourth performs automatic backups of the file being edited on a regular basis. Now, another example is a web server. Multiple threads allow multiple requests to be filled at the same time, eliminating the need to service requests sequentially or to fork off separate processes for each incoming request. There are different advantages of threads. These are responsiveness, faster context switch, effective utilization of multiprocessor system, resource sharing, and communication. Now, responsiveness means if the process is divided into threads, when one thread completes its execution, its output can be returned immediately. Next is faster content switch. Now, because context switching between threads takes less time than process context switching necessitates more CPU overhead. Thread is also an effective utilization of multiprocessor system. We can schedule multiple threads on schedule or on multiple processors if we can have multiple threads in a single process. This will speed up the process execution. Next, we have the resource sharing is also an advantage of threads because all threads within a process can share resources such as code, data, and files. It should be noted that stacks and registers cannot be shared between threads. Each thread has its own registers and stack. Okay? Now, lastly, we have communication. Because the threads share a common address space, communication between them is simplified. We must use specific communication techniques while in process to communicate between two processes. Next on our list of topics is the process scheduling or process scheduler. Now, process scheduler or process scheduling enables the operating system to assign a time interval for CPU execution to each processes. It maximizes the number of interactive users within acceptable response time. Now, in order to maximize the number of interactive users, take note of this, a scheduler, which is a type of system software, is used, okay, which allows us to handle process scheduling. Now, there are three types of process scheduler: the long term, the medium term, and the short term. Now, the long-term scheduler controls the program and selects processes from the queue to load into memory for execution. You can manage the swap out processes using the medium-term scheduler. Now, the primary goal of the short-term scheduler is to improve system performance based on predefined criteria. A long term is also known as a job scheduler. The short term is the short term as a CPU scheduler and the medium term as a swapping scheduler. Now you know what process scheduling and its three types. Here are the important objectives of process scheduling. First is maximize the number of interactive users within acceptable response time. Second, achieve a balance between response and utilization. Third, avoid indefinite postponement and enforce priorities. And fourth, should give reference to the process holding the key resources. So those are the objectives of process scheduling. Now here are the difference between the types of process scheduler. So we will just skip this topic. You can pause this video and simply read the difference between the three types of schedulers, which is the long term, the short term, and the medium term. Okay, next is the CPU scheduling. So, what is CPU scheduling? Now, CPU scheduling is the process of deciding which process will own the CPU for execution while another is on hold or waiting. Okay, the main task of CPU scheduling is to ensure that whatever or whenever the CPU is idle, the operating system selects at least one of the processes in the ready queue for execution. Now, CPU scheduling has other purposes like CPU uses scheduling to improve its efficiency. Next is it helps you to allocate resources among competing processes. Third is the maximum utilization of CPU can be obtained with multiprogramming. And lastly, we have the process which are the executed or which are to be executed are in ready queue. Now, we go to CPU scheduling. Now, a CPU scheduling algorithm tries to maximize and minimize the following. Okay, the first is the maximize. So we maximize the CPU utilization and the throughput. Okay, now CPU utilization is the main task in which the operating system needs to make sure that CPU remains as busy as possible. It can range from 0 to 100%. However, for the RTOS, okay, it can range from 40% to low level and 90% for the high level system. Now, throughput, the number of processes that finish their execution per unit time is known as throughput. So, when the CPU is busy executing the process at the time, work is being done and the work completed per unit time is called throughput. Okay, next we have the minimize. Okay, so under minimize we have turnaround time, waiting time, and response time. Now, waiting time is an amount that specific process needs to wait in the ready queue. The response time is an amount to time in which the request was submitted until the first response is produced. And the turnaround time is an amount of time to execute a specific process. It is the calculation of the total time spent waiting to get into the memory, waiting in the queue, and executing on the CPU. Now, the period between the time to process or the time of process submission to the completion time is the turnaround time. Now, there are different types of CPU scheduling. Okay, first, the first come first serve or the FCFS, the shortest job first or the SJF, the shortest remaining time, the priority scheduling, round robin scheduling, and the multi queue scheduling. Okay, in the first come first serve method, the process which requests the CPU gets the CPU allocation first. In the shortest remaining time or the SJF, the process will be allocated to the task closest to its completion. In priority scheduling, the scheduler selects the task to work as per the priority. The round robin scheduling works on the principle where each person gets an equal share of something in turn. In the shortest job first, okay, the shortest execution time should be selected for execution next. And lastly, the multi-level scheduling method separates the ready queue into various separate queues. In this method, processes are assigned to a queue based on a specific property. The CPU, remember this, the CPU uses scheduling to improve its efficiency. And that's it for this lesson. Hope you have learned something. Thanks for watching.